All right, well, thanks. So I'm the CEO of 5D Robotics. We're a robotics company. Can you guys hear me okay? Yep. So we've been around for about 6 years. We've worked for many years with the Rapid Equipping Force. And the focus on innovation that the Rapid Equipping Force has had within the military has been a great asset for us. So it's allowed us to take technology from academia, from national labs, and turn it into a product that has really been able to make a difference. So our vision is making sure that vehicles can get from point A to point B no matter what, through fog, through rain, through snow, without GPS. We want to work in GPS-denied areas. And what we found is that positioning is really key. So what we do is we've created this solution that we call the Universal Position and Navigation Module. And it's essentially a single reusable module that we can put on anything from drones to ground vehicles, and allows us to make a very wide variety of vehicles, from 7,000-pound tanks to 1-pound drones, autonomous, and allows them to move very reliably and accurately. The actual Universal Position Node, one of the big innovative aspects of this capability is it has inside of it a ultra-wideband radio, and this ultra-wideband radio allows us to get centimeter accuracy so that even without GPS, we can know exactly where we are. So there's really two ways in which we use this. One of them I call virtual rail, and one of them I call virtual tether. So with virtual rail, the idea is you can take an entire ecosystem, like I could take this whole conference center, and I could provide positioning for this conference center by setting up a small constellation of nodes. The other method is virtual tether, and that's really a peer-to-peer connection. So let me show you this video, which hopefully will help explain how this constellation works. There, I figured out how to turn on the sound. I think you have to raise the volume.
Today we were demonstrating autonomous vehicle operation. So in this case, it was scissors that were driving them a lot. They were driving themselves around a lot.
So basically what we did in this video is we put 4 nodes into United Rentals' yard. And those 4 nodes were sufficient to allow these pieces of heavy equipment to drive around by themselves very, very accurately, and do it in a way that GPS never could. So if you look at what happened here, we were able to take off-the-shelf vehicles, in this case very simple vehicles, scissor lifts. Right? It doesn't get any simpler than that. But we were able to turn them into robots. So imagine any piece of military equipment we can add our kit to, and very quickly and very efficiently allow it to drive around. So you'll see in the video there what the tags look like. Those are the militarized tags that we created for the Rapid Equipping Force. And it's so accurate that we can keep the system on what essentially looks to the user like it's on a rail. Right? So this scissor lift is going to follow that rail over and over again to go to the different spots where they want it to go. So in this particular yard, they had 5 different locations where they wanted these vehicles to drive. And it actually allows the vehicles to go up onto flatbeds and off of flatbeds, essentially automating what the vehicles need to do. So you can see in this particular video the different areas where they want the systems to drive. And you can also see how easily this fits into the existing infrastructure. Right? There's no need for them to build a specific rail system. There's no need for them to configure the environment in any special way. So the idea is essentially with only a few minutes of setup time, they can configure and reconfigure a virtual rail environment. And in fact, in this video, I particularly like just kind of showing how the people in the environment begin to get used to the autonomy. So you see that little blue scissor lift is going to do a loop there, and it's just set to do that loop over and over again. And you can see how people interact with the system. You've got cranes and flatbed trucks and forklifts moving around, and they just become very comfortable with the technology and with how it works in their actual yard. And this is important because if robotics is going to be a big part of the future, it needs to be safe, it needs to be comfortable. People have to have a sense that this is a technology they can get used to. So the relative positioning apps allow us to do things like follow. So this was also a REF-funded project. So I can run around. I set a world record having a robot follow me for an entire day. It's a wonderful way to get rid of all the problems with robotics that most people are usually plagued with. Because in this video, there's no GPS. There's no way that dust or fog or rain can interfere with this system. A lot of people don't realize that robots always work well in YouTube videos, but trying to get them to work out in Fort Leonard Wood and Fort Benning when you've got lots and lots of dust obscuring the lasers, obscuring the cameras, that's really the challenge. And the ultra-wideband technology allows us to do that. You see here there's tons of dust in the way. You also can see that there's all different robots that we've put this system onto. So this particular video is a Northrop Grumman system. It's got 6 wheels. Notice there how it doesn't hit its back wheel as it's trying to get through that dust and vegetation. In this video, you see what we call a breadcrumb follow. Imagine you're going on a precipice. You're doing essentially switchbacks up a mountain. Knowing that the vehicle will take the same exact path that you took is really key. Right? So if you watch carefully, you can see the robot's not just following the person, it's actually following the path that they took. And that's really critical. In this video, you can see that you can actually wagon train a bunch of these little guys together. Right? So you've got a 7,000-pound Mesa Acer, which is a combat engineer vehicle used for landmine detection. But you also have a little Segway in the back. So the point is, whatever the system is, they're all just taxi cabs to us. And essentially, whatever vehicle the military wants to use, we can make intelligent. A great example of this is what we're doing with drones. No one else in the world can do this. You want to talk about innovation? This is a fantastic opportunity because it allows us to take these very inexpensive drones, fly them in 25-mile-an-hour wind. Look at those trees. Look at how the trees are moving, right? There's no human control of this vehicle. And the vehicle, the drone, is able to stay a fixed distance, even in this very, very difficult wind. It's also able to fly in this tight space, right? So it's not hitting the trees, it's not hitting the people, it's not hitting the buildings. Raise your hand if you've ever tried to fly a drone with GPS. Anyone? A couple people? Yeah. So there's no way that you could ever try to do this with GPS. No way. So on YouTube, you see all these videos of people showing autonomous follow with drones. You can't do this kind of stuff. You have to have the drone way up in the air because GPS just simply isn't accurate enough. But with our technology, I can be going along power lines. Imagine this is a utility road. We're working with one of the big utility companies to show that essentially, if you set up this drone to do what we call virtual tether, you can just drive along the utility roads, not have to worry about flying the air system at all. You don't have to be a pilot. If you can drive a ground vehicle, you can essentially be building up these maps, right? So what you'll see here is that a map is generated autonomously. The person doing this has absolutely no idea how to fly a drone. They have no idea, how to do anything regarding robotics or how to do mapping. But you'll see an autonomous map gets produced here without any operator workload. So this is the map that's autonomously produced, requires no human involvement. And you can see it's not a perfect map, but to be able to produce a map like this without any kind of robotics expertise is really the holy grail. And I think we're, like I said, about the only company in the world that can really do this reliably out in the field. One of the other big things is that we can do this without any dependence on GPS, which is what allows us to do this with confidence. So this is the latest sort of productized version of this. So I'm going to show you a video here that's really cutting edge, and it comes out of a collaboration that we have with Innova Drone and SkySense, which are both part of the Qualcomm Technology Innovators Center. And so we built the ultra-wideband universal positioning node into this drone. So what you're going to see here is the drone port, right? So the drone port you can have out in the middle of nowhere. You can have out, 100 miles into the desert. You can have this drone port on the back of a pickup truck. So, if you have an F-150 pickup truck, put this drone port in the back. We call it the eagle's nest, right? And again, you have no dependency on GPS and no need for a human operator, right? So this thing can fly out, can do the mapping autonomously. And unlike any other technology out there, this thing can land back on that charging pad and automatically charge itself. GPS-based approaches that try to do this, they're lucky if they can get it to work 1 time out of 5. And if I have a $150 jamming device, I can make the drone fall out of the sky. Right? There's no way that that technology is going to be utilized by utility companies because it's too dangerous. If one of these drones hits the power line, it can cause billions of dollars of damage. That's why having a solution which isn't dependent on GPS is absolutely critical. There's a ton of these capabilities out there. A lot of companies are raising money for this right now. But if they don't get the reliability down, they're not going to be able to produce big advantages. So this is something that we did for the Army. This is an Army conference, so I figured I'll show at least one Army video. Of course, the other ones I showed have to do with our work with the REF. So this is a video that needs some explanation. So essentially, a drone takes off of a ground vehicle. It builds up a map. So this is the map. This is the 3D map. You can see some of the holes there. So within a few minutes, I've produced a 3D map of the environment. This is a wonderful location at Picatinny Arsenal. The user can just simply select a rectangle within the map. The ground vehicle will now go out and get perfect centimeter level coverage of that ground. There's, again, no way that you're going to do that with GPS. But what's even more important is that the system correlates the aerial map with the ground vehicle position data, which again is extremely difficult to do. So not only do you get perfect coverage of the ground with this revolutionary electromagnetic induction sensor, but you're also able to then walk out yourself holding a tag into that environment, see where you are in the map, and dig right over that red spot. In this particular video, you can see the landmine roll out. So instead of digging as a human in the minefield, you've got a vehicle, the combat engineer from Acer, from Mesa, called the Acer, that allows the vehicle to go out and flail the ground and disrupt or neutralize that hazard. So essentially, not only can we do autonomous detection, but we can also do autonomous neutralization. And this was a real live test. We were able to find every single anomaly that was in the ground and mark it effectively. So this centimeter level accuracy and the correlation between the data collection on the ground vehicle, the 3D map from the air vehicle, and the neutralization vehicle is quite a revolutionary capability. Got one more video that I'm going to show you. This is a video of what we did at Camp Lejeune. And this again shows the integration of several different capabilities. You hardly ever see this in robotics, where a lot of different mission level capabilities are all built into this scenario. So Wes Bryn was talking about the need for innovation. This was a project that he really helped us put together. This was a very revolutionary capability to go out and use air systems, multiple ground systems, and put all of this technology together into a working whole. So again, the sound isn't working real well here, but I'll give you the voiceover. So we had a bunch of different robot companies that came out and supported this. This was actually funded through the Office of Naval Research. We had a couple of drones, small lightweight drones. We had a couple of ground vehicles. Unlike the last video that you saw, we also had a 3D mapping capability based on laser that was able to localize the entire mount facility at Fort Benning, actually at Camp Lejeune, I should say, down to about 10 centimeters. So this is the laser mapping payload, which incidentally we can now put on either the air vehicle or the ground vehicle, right? So it's a removable plug-and-play payload. And this allows the vehicle to build up a map that's in 3 dimensions and actually gave the Marines a very good situation awareness, a very good understanding of whether they could fit through windows, whether they could fit vehicles through doors, because the laser map is so accurate volumetrically. So this is the whole area mapped out with the laser. You're able to see the height as well. And this is one of the drones that we used. So this drone actually did over 75 flights during that week. And the actual Marines never had to fly the vehicle directly. So all of the UAS operations could be done autonomously, which is really important. And from a maneuverability, from a portability, they love the fact that this drone only weighs like 7 pounds, right? So it's like, what would you rather have? A, you know, many 100-pound ground vehicle that you're responsible for, or a little tiny drone that you can take out of your backpack, right? It's kind of a game changer. But again, to be able to use this technology well, it all comes down to reliability and training. The fact that they didn't have to go through training to be able to use this was a pretty important feature. So you can see the 3D map capability that we're showing here, where the drone is able to build up a highly accurate map. And again, as this video progresses, you'll see the ability to take these different maps and fuse the position reference from the air and from the ground so that everything is correlated effectively. In fact, this is a perfect example. So again, that's a 3D map from the air, but I can then go out and collect ground vehicle data and store it inside of that map. And it was really fun. In terms of innovation, one of the things that was compelling about this is we put the technology into these Marines' hands without really having a very specific doctrine for how it was going to be used, right? No one knew. No one has ever had these capabilities before in the history of mankind, right? So there's no way that they would know how to use the technology, but they're very smart. And given a week to play with the technology, they figured it out. And I would argue they figured it out better and faster than if you got a whole bunch of military brass in a room and just, you know, had them essentially do the usual IPT meetings, right? These guys could actually take it out, kick the tires, try things out, make it work, see what worked, what didn't work. I've always said in robotics we should enable appropriate distrust as much as we work to enable appropriate trust, right? Because if people understand how to use the technology, they can really accelerate that process of innovation, which isn't just assuming that all the technology works perfectly, right? Because it never does. It's really a process of figuring out how to get value out of the technology. So that's basically all I have for you today. But hopefully you've had a chance to see that this fundamentally new innovation of using ultra-wideband positioning is going to change everything. It's going to change the way that we think about military operations because it allows us to fuse all these disparate vehicles. And it's going to change the way we think about transportation too. Right now we have projects with some of the biggest companies in the world, not only moving this technology into places like United Rentals Yards, which you saw in that other video, we're also doing autonomous driving. Imagine the UPN on thousands and thousands of cars moving together on the highway, where that peer-to-peer positioning allows each vehicle to wagon train, to move together effectively, and to be safe. That's really the future. And I'd like to see that technology go into industry and the military simultaneously, because that's where we get the biggest benefit. So Bill, that's all I got.
Test.
Okay.
So in your concept, all the vendors here on the 2 floors here at the convention center, can they take your technology today and embed them into their own UAVs and their own robotics? And where are we on that discussion? Is that
Yeah,
happening?
that's a great question. So is this on? Yeah. So the whole idea is that within literally like an hour, I can take some new vehicle, whether it's a forklift from Toyota, or whether it's a ground vehicle from Northrop Grumman, whether it's an air vehicle from Sci-Fi company that's sharing our table, and to us, they're all just taxi cabs. They're all just ways to go out in the world, collect data, and so our job is to make sure that we provide accurate positioning and effective, robust behavior. We've put the technology so far in about 35 different vehicles. And we're very excited about putting it onto other vehicles too. So if you have a vehicle out there and you're worried about GPS denied situations, if you're worried about collecting data more accurately than you've been able to, for instance, in petrochemical plants, if you collect data right now with GPS, it's not certifiable, right? The regulators won't accept it. With our technology on board, we can guarantee 2-centimeter accuracy, so that all that data that you collect is now much, much more accurate and more reliable. So if you have an application where, reliability and accuracy is important, we'd love to talk to you.
And does that work in tunnels, subterranean, or?
Yeah, in fact, a lot of our background, Wired Magazine did a couple of articles on us a while back because we were the first people to chart out a bunch of the border tunnels. We did a lot of work with the military on that, with ERDAC and some with the JAEDO, basically showing that we can build up maps through tunnels, that we can localize in tunnels, even tunnels that were 30 feet underground. So to make it really clear, we're not dependent on any external source like GPS. So for tunnels and bunkers and caves, the technology works great. But a lot of people don't realize GPS doesn't even work in parking garages, right? So it's not just for the sort of classic tunnel environments. It's really for everywhere where GPS doesn't work, like this hall we're standing in right now.
Okay, I don't want to take up all the question time. Any questions? Thank you, sir. That was excellent.
Yep.